YouTube channel. This is Simplified series. Now the topic for today, we'll be looking at what we term as rigorous proofing is under set theory. And what are the things we have to note under rigorous proving? Things to note. So one of the things we have to know is we must know that the symbol E stands for element, and 2, the symbol E/ stands for not an element. And also we need to know that we don't make use of equality for proving. Instead of making use of equality for proving, we will rather change this equality to 2 prepositions, and it will be mixed with what we term as a subset. See, rigorous proving is very easy if we can note all these things. E stands for element, not of E stands for what? Not an element. We don't make use of equality to prove, we make use of a subset. And also we must know that we have to prove that the left hand side is a subset of the right hand side, and also that the right hand side is a subset of the left hand side. So these are the things we need to know before we move to rigorous proving. And also we need to look at expansion. And what is the meaning of expansion? Expansion in the sense that if we have A intersection B union C, how are we going to resolve it? Now for this, we will relate this with something like 2 plus 4 times 5. If you want to expand this, any sign or any symbol inside the bracket, we change it to addition, and any symbol outside the bracket, we change it to multiplication. So if you want to expand this, what do we have? We have it as 2 times 5 plus 4 times 5. So the same thing, let us relate this with this. This will change to addition and this will change to multiplication. So how can we multiply? It will be A times C. That will give us A union C. Then the addition B times C, and that will give us what? B union C. Now also let us try to look at another example of this. We have something like this, A which is A union B intersection C. That means any symbol outside the bracket is the multiplication and inside the bracket is the addition. So let's multiply. What do we have? We have it as A union B intersection A union C. And that is how to expand. This is intersection, not addition. And also, apart from the expansion, the last thing we need to know under the rigorous proving is something I framed or termed myself as a vibration. And what is the meaning of vibration? What am I saying about the issue of vibration? Vibration is this: we must always leave all our proving in terms of element. But we must note that there is a way your element can change to not an element, and there is a way you can change your not an element to element. Anytime an element is changing to not an element, and anytime not an element is changing to element, there will be something we call vibration. And when we are talking of vibration, anything in front will change automatically. Let's look at cases of vibration. Let's look at number 1. X is not an element of A, union X is not an element of B, union X is an element of C. Now I've said something that if you want to prove under rigorous proving, we must always leave our answer as an element. That means we now have X is an element of. That means not an element as changes towards an element. That means there will be a vibration. And when there is a vibration, the vibration will stop anytime we are saying X. So because of the vibration, A will change to A complement. This union will change to intersection. Now X is coming in. So since X is coming in, this first vibration will stop. And then we have it as X is an element. Not an element also will change to element. That means, there will be a vibration in it. And what do we have? We have it as B prime intersection the vibration we stop, and this will give us S is an element of C. Now we cannot assume that S is an element is common, and what do we have left? A prime intersection B prime intersection C, and that is a simple explanation to it. Now also to buttress more points on that, let us look at this example. We have X is not an element of A intersection B union X is not an element of C intersection S is an element of D. Wow! So how can we break this down? We have said something that we don't leave our answer as not an element of. So that means we change this not an element of to element. There will be a vibration, but the vibration will not affect this symbol because it's inside the bracket. That means we will now have it as what? A intersection B. The vibration will bring a complement. There is still a vibration. This union will change to intersection. The vibration will stop anytime we are having X, and that means X not an element will change to element again. The vibration continues. We have C prime union. The vibration will change this to union. X is an element of D. So that means what? We can easily say that X is an element is common. And what do we have? A intersection B prime intersection C prime union D. And that is a summary of rigorous proving. Now let us now start by solving series of questions. Now the first one is this. We are going to prove the following. We have number 1, prove vigorously that A minus B is equals to A intersection B complement. We have said something. Let us now look at all the applications. We don't make use of equality to prove. That means we have to change it to what we term as a preposition. And we have preposition 1, and also we have what we term as a preposition 2. Now for the preposition 1, we are going to assume that the left hand side is a subset of the right hand side, and for the preposition 2, we are going to assume that the right hand side is a subset of the left hand side. So now let's look at how to prove. For you to prove vigorously, the first thing is this: you have to assume X to be an element of what you want to show. That means X is an element of A minus B. We are now going to prove this man to be equals to this. Now let's start. So that means, what is the meaning of minus? Minus means not an element of. So that means we are having it as X is an element of it. Minus means and X is not an element of B. So what do we have? X is an element of it. What is and? And means intersection. X, we don't normally work with not an element. We change it to element. What will happen? Vibration will occur. And that will give us what? B complement. So what is common now? X is an element of A intersection B complement. And that is what they are asking us to prove. Therefore, we are now going to show that A minus B is a subset of A intersection B complement. Now, for us to prove for the preposition 2, we don't need to start wasting our time. All we just do is to copy it backward. Normally, they will say something that photocopy is not easy, but sincerely, photocopy is easy now. So we are going to take it down to S is an element of A intersection B complement. And since we have proof for this man, we are just going to copy it upward. So what is this line? We have it as S is an element of A intersection S is an element of B complement. The next line is what? S is an element of A and X is not an element of B. What is the next line? S is an element of A minus B. And that is what we are asked to prove. Therefore, we have it as A intersection B complement is a subset of A minus B. Now, since this one is a subset, and since the second one is a subset, we will now conclude that hence our A minus B is equals to A intersection B complement. And that is that for rigorous proving. You can see that is very, very simple, if only you understand the basis. Now, to solve more questions, let us look at the second question. And the second question is this: they are asking us to show rigorously that A union B complement is equals to A complement intersection B complement. So what are we going to do? I've said it. We are going to change it to two preposition and mixing it with what? With a subset. So preposition 1, what do we have? We have it as A union B complement is a subset of A complement intersection B complement. And what is our preposition 2? Our preposition 2 will now be from the right hand side, which is A complement intersection B complement, to be a subset of A union B complement. Now let's begin the journey. And what is the first journey? We have it as S is an element of A union B complement. We cannot do anything until this complement changes this to what? Not an element. So that will give us S is not an element of A union B. And from this we have to expand. This time this will give us S is not an element of A union X is not an element of B. And I've said it, we don't normally work with not an element. What will happen? We now have it as what? S is an element of vibration will occur. That will give us A complement intersection X is an element of B complement. And what do we have? S is an element of A complement intersection B complement. And that is what they ask us to prove. Therefore, we assume that what our A union B complement is a subset of A complement intersection C complement. And for this, we don't have to waste our time again. I've said it, what we just do is to copy it backward. And from this is what we are having, then we copy it backward. This line is S is an element of A complement intersection S is an element of B complement. This will give us X is not an element of A union X is not an element of B. This will give us X is not an element of A union B. This will give us X is an element of A union B complement. And that is what they ask us to prove. Therefore, A complement intersection B complement is a subset of A union B complement. And that means this one and this one, they are true. Therefore, or hence, our A union B complement is equals to A complement intersection B complement. You can see that it's simple. Now let's keep on solving questions. Let's solve questions. The more we solve, the more we know. So let's solve another question. And this question now we are going to be mixing three sets together. For example, that will give us the example 3 we are solving. And they are asking us to prove vigorously that A intersection B union C is equals to A union C intersection B union C. Wow! So how can we solve this? It's still the same process. That means we have the first man to be the first preposition 1. That means our A union B A intersection B union C is a subset of A union C intersection B union C. And also we have our preposition 2 to be from the left hand side. That will give us A union C intersection B union C is a subset of A intersection B union C. Now let's begin our journey. Now don't forget there is a secret about this. It will get to some stage where it will give us a kind of little issue. But when we get there, we have to know that any symbol in between is addition and this one is multiplication. So let's begin. We have X is an element of A intersection B union C. Then we expand. What do we have? S is an element of A intersection B union X is an element of C. Then we still expand. That will give us S is an element of A. What is intersection? It means and X is an element of B. What is union? It means or. X is an element of C. Wow! When we now get to this stage, we are now going to apply a little of English language. Now let us look at this. X is an element of A and X is an element of B, or X is an element of C. That means there is a way we can combine C with A and B. So how can we combine? This will now give us X is an element of A, or X is an element of C, and X is an element of B or X is an element of C? Can we get it now? It's very, very simple. And what do we have? They match this and this together. That means we are going to match them together. We have X is an element of A union C. Intersection S is an element of B union C. And what is common again? S is an element is common. What do we have? A union C intersection B union C. And that is what they ask us to prove. Therefore, we conclude that what A intersection B union C is a subset of A union C intersection B union C. It's simple. And we don't need to look at preposition 2, but let us look at it just because it's still the same thing. We just copy it backward. But let's look at it. We have X is an element of A union C intersection B union C. We don't have to waste our time. Just let us copy it backward. S is an element of A union C intersection S is an element of B union C. Copy it backward. S is an element of A or X is an element of C, and X is an element of B or X is an element of C. We have X is an element of A and X is an element of B or X is an element of C. Copy it backward. S is an element of A intersection B union X is an element of C. Copy it backward. X is an element of A intersection B union C. Therefore, we can now conclude that what A union C intersection B union C is a subset of A intersection B union C. Hence, we can now show that what A intersection B union C is equals to A union C intersection B union C. And it's very, very simple. We can keep on repeating a lot of examples and examples and examples, but let's not look at questions that involved negative sign. And don't forget, we have studied that when we are having negative sign, what is the meaning of negative sign? Negative sign simply means not an element of. Questions like this, they ask us to show rigorously that A intersection B minus C is equals to A intersection B intersection C. Don't be scared, it's very, very simple. We have looked at the basics and we are just going to be applying that basics. The first one, we said we are going to change it to two preposition, preposition 1 and preposition 2. So we are going to deal with preposition 1 and then we copied it backward for preposition 2. So let's begin to solve. That will give us S is an element of A intersection B minus C. And what is the meaning of minus? It means S is an element of A and intersection B. Minus means and X is not an element of C. And now this will give us X is an element of A intersection B intersection X is an element of C complement. Oh, sorry, there is a mistake here. There must be a complement here. So now let us look at it. We have X is an element of A intersection S is an element of B intersection S is an element of C complement. And what is common? S is an element, and what do we have? A intersection B intersection C complement. So please take note of this complement. And also for the preposition 2, what are we going to do? We are going to have it as well. A intersection B intersection C complement is a subset of A intersection B minus C. And we don't need to prove this again. We are going to copy it backward just because we have S is an element of A intersection B intersection C complement. So we are not going to solve this. That will be a practice question. Just continue with it. I've explained you just need to copy it backward. You assume that this man is a subset. Copy it backward. Assume that this man is a subset. And then we equate it. So to solve more questions, we are going to be proving only for the preposition 1. That means for the preposition 2, I've said it. For you to prove for preposition 2, just copy it backward. Now let's look at another question. Now let's look at this. We prove rigorously that A minus B minus C is equals to A minus C minus B minus C. Wow! So how can we prove this? That will give us S is an element, preposition 1. That will give us S is an element of A minus B minus C. And this will give us S is an element of A minus B, and X is not an element of C. This will give us S is an element of A, and X is not an element of B, and X is not an element of C. The same thing, we are going to use English language. S is an element of A, and X is not an element of B, and X is not an element of C. That means we can also mix these together. We can also mix S is not an element of C with A and B. And what will that give us? That will give us S is an element of A, and X is not an element of C, and X is not an element of B, and X is not an element of C. Now looking at this, that will give us S is an element of A, this will give us minus C, and X is not an element of B. So this will now give us S is an element of A minus C, and also this will give us minus B minus C. And you can see we have shown that the left hand side is a subset of the right hand side. That means we can prove for preposition 2. And what do? You just copy it backwards. So don't let us waste time on this. Let's just solve more and more and more and more questions. Now let's look at the second to the last question just for this video, and that will give us a question that looks like this: A union B intersection C is equals to A union B intersection A union C, and that is the multiplication and the addition that I explained earlier. So that means we are going to prove only for the preposition 1, and you can prove for the preposition 2 by just copying it backward. So let's look at it. We have A union B intersection C is a subset of A union B intersection A union C, and that will give us S is an element of A union B intersection C, and that will give us S is an element of A union X is an element of B intersection C. And what do we have? S is an element of A, or X is an element of B, and X is an element of C. And how can you combine this? You can always combine A with these two. And how can you combine? That will give us S is an element of A, or S is an element of B, and S is an element of A, or S is an element of C. And you can see they mix A and B together and A and C. That means we are going to mix them together. And this will give us A, or means union, B. And what is AND? Intersection. We have S is an element of A union C. And S is an element is common. What do we have? A union B intersection A union C. And that is all. That means the left hand side is a subset of the right hand side. And for your preposition 2, the right hand side will be a subset of the left hand side, and we are going to copy it backward from this place upward. And then we will conclude that this man is equal to this man. And that is simple. Now let's solve the last question under rigorous proving. And this is the last question under rigorous proving. A minus B union C is equals to A minus B intersection A minus C. So how can we prove it? I will just prove for the first preposition. The second preposition is easy, and then you conclude. So that means we are going to be looking at this preposition, preposition 1. We have A minus B union C is a subset of A minus B intersection A minus C. And we have said it, we assume x is an element of the left hand side. And then the journey begins. So let's begin the journey. Expand. S is an element of A, and what is minus? X is not an element of B union C. And that means we are still going to expand. S is an element of A, and X is not an element of B union. S is not an element of C. And what is the meaning of union? It means up. And also, there is a way you can combine these. Sorry, it's A, and A is involved in everything. There is a way you can combine A with B and C. So that will give us S is an element of A, and X is not an element of B, and X is an element of A, and X is not an element of C. And that means they are grouping A and B and A and C together, and that will give us S is an element of A. What is and not an element? That will give us minus B. What is and? Intersection. X is an element of A. What is and not an element? That will give us what? Minus. And therefore we can conclude that X is an element of A minus B intersection A minus C. And that means the left hand side is a subset of the right hand side. And we don't need to look at preposition to again, because I've said it is a repetition. We just copied it backward, saying the right hand side is a subset of the left hand side. And that is a summary of rigorous proving. And what have we looked at under rigorous proving? We said the first thing we must know that the symbol E stands for what? An element of. The symbol E slash stands for what? Not an element of. And we don't conclude our proving with not an element, we conclude it with element. And what is the next thing we have to know? We have to know that your elements can change to not an element, your not an element will change to element. But if they are changing, what do we need to know? We must know that there will always be what we term as a vibration. And the vibration stops when we have the value of x. That means anything in front will change. If we are having union in front, it will change to intersection. If we have A in front, it will change to A complement, and so on and so forth. And you can see the rigorous proving is very, very simple. I remain my humble self, Titiano. Please don't forget to like, share, comment, and please don't forget to subscribe. I love you. Thank you very much. This is from Simplified. Thank you for always viewing our channels. Thank you for always liking, and thank you for always subscribing. We promise to keep on imparting lives and keep on simplifying student affairs. Watch out for our next video, which will be on partial fraction. And come and look at how Simplified will help you guys to simplify and to break down partial fraction. Thank you very much.